Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and today we're continuing with our Python Certified Entry-Level Programmer objectives by taking a look at data types. And we're going to begin by looking at Boolean values. Boolean values can be a simple true or false. They must be, though, in the correct case. So we must be using an uppercase T and an uppercase F with everything else being lowercase. They're the only acceptable values. These are often used to test logical conditions, and we'll be able to see this in some of the definitions and demonstrations. When we look at integers, integers are whole numbers. They might be positive or negative, but without decimal places. They are whole numbers. They're represented by the data type int in Python. If we're not dealing then with whole numbers, we can be looking at floating point decimals. Our floats represent real numbers that include decimal point. They're represented by the float data type in Python. When we look at some additional notes on this for the PCEP exam, we can use the type function to check the data type. And if we're going to combine integers and floats together, they can, and typically they're going to produce a float as the result. When we're looking at the key differences to summarize some of this, we can see then that our Boolean is going to be true or false. Great for logical values and comparisons of conditions. Integer, so it can be negative numbers, it could be 0, it could be 1, 2, 3, but we're talking about whole numbers without any decimal places. And then when we're looking at our floating point decimals, then we could have something like the value of pi, 3.14, or even negative values like negative 0.01, so numbers with decimal places. We're going to dive out now and take a look at the demonstration. In the demonstration, we're going to be able to look at using Booleans, using integers, using floats, and of course, testing data with the type function. So come on, let's see if we can find our Jupyter notebooks. And in doing so, we can begin by taking a look at our first data type, Boolean values, simple, true, or false. And look at this, our glorious Jupyter notebook running on my Ubuntu system, but it really doesn't matter what it's running on. We just need to learn a little bit about, in this case, we're going to be starting looking at our Booleans with a simple true or false value. Are you ready? Well, let's go. We're going to create a variable. Now, I know we haven't looked at variables yet, but it's like any language. If we become accustomed to it by seeing it being used, then we're going to be learning anyway. So I'm going to set myself up a new variable here and then assign it a true or false or Boolean value. So let's call it raining. And then we can use equal, the assignment operator. And look at this, we just put the word true with the uppercase T. We can see that it comes back highlighted in green, so it's recognized as something special in the language. So this is what we mean by Boolean values, a simple true or false, but in the correct case. But if I look at my variable, very often with these Boolean values, we would call the variable something like this, is underscore raining. It's going to be a lot more easy to understand the purpose of the variable if we put something is underscore in front of Boolean values, because it's a simple test, yes or no, true or false, remembering that we can only use true and false values. To execute the code, I can use Shift and Enter, and we can see nothing is printed. We have just simply assigned the value to the variable. But I can check then the data type of my variable using the type function with is raining as the argument, And we can see then that it prints the word bool for Boolean. So we have correctly stored the value here. If I go through and paste this down, if I change to a lowercase t, you can see there's no longer any highlighting. If I try and execute that code, we get a name error exception. It's looking for a variable called true or some form of object in the code called true, and there isn't anything. So we have to keep the correct case. True or false are the only words that we can use, and we have to use the correct case. Now, did I say we could use true or false? Well, let's go through and try this. Put false. Oh, and look at that keyword again. It's coming back highlighted in green. I can go through and run the second cell, and of course that's just going to return that it's a Boolean still. But I can now go through and actually start using my variable in an if statement. Now, I know we haven't looked at conditionals, but they are not that difficult, and we can become familiar. So if is underscore raining. Remember, this is just going to be a true or a false. We can then put our colon block after that. And then we can say, well, look, if it is raining, then we can print something like, well, let's stay inside. We don't want to be going out. It is raining. So we can stay in. We can then build in a conditional statement else. Now let's miss out the colon here. We know we should have a colon, but see what the code reports back to us. We can then say, well, look, if it is not raining, we can go out. Else is great for us here because we only have two conditions to test for. Let's go through and execute the code, and we were predicting an error, but look how good the code is. It tells me that there should be a colon after else. Now, as we execute our code, we can see that we are safe to go out. Well, okay. Let's go back to is raining and put that to true. Make sure we execute that code. And now when we get down to our code block, we can see that it's raining, so we should stay in. You certainly managed to do that very quickly. Well, if you're so good at that, why don't we now take a look at our whole numbers or integers? And yes, we're about to dive into the wonderful world of integers. We've already taken a look at our Boolean values and seen that we can have the true or the false so long as we're using the correct case. We can check the data type using the type command. So much of what we've already learned we're going to be able to carry forward, such as setting variables and using the type command to query our data type. So are you ready to get started with integers? I think you're about ready. So let's go through and create some variables that we can work with. I could use variables or I could just use the numbers themselves. But we get used to using variables. I'm going to use some really simple variables now, just with a single character. So not a great idea, but good enough for a demonstration like this. Normally our variables should be easily understandable about what they're containing. But here if I put a equals 10, 10 is a whole number, so it's an integer. And when I look at the type of a, we can see then that variable a is in fact an integer, or currently it contains an integer. The whole thing with variables is that they could change their values stored. We can set up another variable. Here we can call it b. b has a value of 3. It's a complete or whole number, so it too will also be an integer. I don't think there's much need to go through and run the type command against b. But what if I start combining integers together? If I look at c and assign c the value of a added to b, so a plus b, well, two integers added together is always going to result in an integer. So when we look at running this and taking a look at the value of c, we're going to be able to see that it has a value of 13 and, of course, that is an integer. So two integers added together is always going to result in another integer. But if I do another calculation where I have my variable d is assigned the value of a divided by b, so 10 divided by 3, and if we look at the result, well, we can see then that this is not a whole number. It contains a fractional part after our decimal place. So this is in fact a float. And we can, of course, now go through and check it. We know how to do this with our type. So type D, and we can see then that the function type is returning a float. But there is more than one type of division. Let's set up another variable. We can call this, I don't know, E seems like a really good name the way that we're going. And if we use the double division, this is the floor division operator. A floor divided by B. So we've got 10 floor divided by B. How many complete versions of B do we have in A? This is going to return the integer portion of the division. So when I look at E, it has a value of 3. 3, of course, is an integer. When I go through and double check that, we can see when we look at type, yes, I was right, it's an integer. So we are not lying here. But it's introduced perhaps a new type of division that you weren't used to before, where we look at floor division. We'll just continue a little bit more, setting up another variable. And as I said, even though we're using the single character names for variables, if I went back through my code, it would be hard to recognize what D, E, F, and so forth would be. But let's set up a variable called F. And if we set that to 4 dot, even though you might argue that this is a complete or whole number, it's going to be stored as a float. So if I look at the type of the variable f, we can see that is a float. In the same way as I put it even to 4.0, again, I can see that you might still argue that 4.0 is still a whole number, but because we put the dot or the dot 0 after the 4, it's going to be recognized as a float. And again, running the type command against our variable f shows that it is, in fact, a float. So as soon as we start using the decimal place, then we are creating a float and not an integer. Integers are complete numbers without the decimal place. Any number with a decimal place is going to be a float. For this video clip, we have one more, yes, just one more data type to investigate, and that is going to be our floats. So let's dive back to our wonderful Jupyter notebook, and we've already seen a little bit of our float, and we can see then that our float is any value that includes the decimal place. So it could be 4 point or 4.0, or as we saw earlier with our division, 3.33. Now we've seen then that we can work with our floats, so our real or whole numbers with decimal places. But we can also work with other numbers. So let's go through and import math. Now again, don't worry too much about what we're doing at the moment, but we're importing a Python library that ships as standard with Python, so we don't need to install this. This library is going to have elements stored in it, such as functions, classes, and variables. And we can access then our value of pi. I know it to 2 decimal places, 3.14, but I'm not that into math to learn it to more decimal places. But if you need to do calculations with an accurate value of pi, then we can set up our own variable. My underscore pi is assigned the value of our math library, moving into the namespace math, and then the variable .pi. Shift and enter on this, we're going to populate my variable, and now when I go through and investigate the contents of this, we can see then that it contains 3.1415926, etc., etc., etc. So we can get a much more precise value in our calculations. Now, this is great if we need that level of precision. However, if that level of precision isn't needed or isn't going to work well for us, if we're doing some simple calculations, maybe we need to round them up. So we have the round function. We could then round my pi, comma. This function takes two arguments. Our first argument is the number that we want to round up. And then the second argument is the number of decimal places that we want. So we can see that we have ended up with 3.14. In doing so, I haven't changed the value of the variable mypi. I've just looked at the output of the round function. At no stage did we reassign mypi with a new value. So if I double check this and read the value of mypi at the moment, when I hit Shift and Enter, we can see that it's still the long version that we inherited from the maths library. If I do want to reassign, I can go back and I can go mypi equals the rounding of mypi to two decimal places. Now, when I print out the value of mypi, so Shift and Enter here, the variable now stores 3.14. So be very careful about this. Do we want to reassign the value of the variable? Do we want to create a new variable? Or do we just need to output the value of the rounding up?